it is of div 2. So the first question is, you are given a string s of length and consisting of only a lower case English letters. A string is called a odd string if and only if, and there are the conditions. If si equals to sj, so j minus I should be odd always. If there are two repetitive means equal characters, then distance between them cannot be even. Okay, so let's suppose there are two conditions. If a character has two a, so what is the difference for now? 1. If I put a, the difference is 2. a, then difference is 3. So this is valid, this is valid. Let's see here now. If I put 1a here, what will happen? The difference between this a will be 1. But difference between these two a's will become 2. So this is not valid because if same character of a is there, so 1, 2, 3 is there. So their difference cannot be 2 indexes. Okay. So for second case, first case it is okay. For second case, there is a difference of 2, it is not possible. But in this third case, it was possible because the difference was 3 for now. But what if I want to add one more where I can add? It is, suppose it is 0, 1, 2, 3. The difference between those three is 3. Let me remove this. Is 4, 5, 6, 7, 8, 9. Now wherever I have to add a there if I am adding a here for a now, it will become this difference between these two become 4 and these two become 7. So I can't add here. Oh, so if may I add here, but here here the difference between will become 2. You can see 1, as we know the difference between two odd distance is always even. See, if one second number is odd, the difference between these two numbers will become even. So here, if we have three similar characters, then see the difference between these two will become odd. Difference between these two is odd, but odd plus odd equals to even here for now. Okay, and if this distance is odd and this distance is odd, see if this distance is odd, wait a minute. If this distance is odd and this distance is also odd, so odd minus odd will become even. So here we can see that we can't have map means count of particular character greater than 3. Okay, we can't have this. One condition is this, so it become our first condition. Now, so if they are double characters, so it is possible to have this. If there are single characters, it is always to have passage. So only the condition is if count is greater than equals to 3, our answer is false. True. We have seen the second means if count is greater than equals to 3, our answer is none. What if count equals to 2 for all? then it is possible only now, because each will have difference. One or null means f, it is the count. If the count is 2, it is possible. If count is 1 also, it is possible. So for if the k is greater than or equals to 3, then our solution is no, else our solution is yes always. Okay, we have mapped it. We will see if the count of each character is greater than or equals to 3 or not. If it is greater than 3, we will say no. If it is less than 3, we will say yes. Okay, now we will see the question, odd operations. Okay, here we have two operations. We can either choose first operation or second operations. In first operation, we have to take any digit from this number n, and minus that digit with the number. Okay. In second, we can rearrange, and we have to make odd n as an odd number by using this number, and we have to print -1. It is impossible to make. See, first of all, we have to make n equals to odd with list operation. Okay, so I will note down. See, you have two operations, n minus any digit of n, or second operation is rearrange, and we have to what we have to do, question mark, minimal steps to make n odd. Okay, so we can do rearranging in one operation. It will cost 1. Each operation will cost us 1. Okay, first we will see, what if our string contain odd. We will directly rearrange it and put at 1. Means rearrange itself means, see, rearrange means 1067, we can do 7106 10670, but not that. Means we can do rearrange of the digits. Okay, so suppose 112 is there, we can rearrange it to 2111, or anything 122 111121, like that. So if we contain any digit which has odd, we can do it in one step. Okay, so I will write here cost. So it will cost only 1, because we will directly rearrange, because it has 1 inside, odd integer inside it. Okay, second case is, if string of n is odd only, then case becomes 0. Cost becomes 0 only, no? If it is odd from starting only, it contains odd is something different. But if it is odd only, then it becomes 0. If it is contain any odd, then it will become 0, 1. Okay. See, for even, we will see cases first of all. So here we will see first 246. Here what is happening? We will subtract it by 6. It will become 240, and 240, it will become 240. Then we will subtract it by 2 or 4. Anything, it will become 238, and it will contain our odd string, and we will rearrange it, and it will give us odd. Okay, so how much it costed? 1 2, and for rearranging it will cost 3. Okay, so we have to know that I got to understand that what is happening if if our last digit is, if we have anything, see, our string is even for now. Our string is even. Huh. And whatever we have in last digit, if we have anything greater than it in our string before, then if we will decrease it by, see, if we have 246 here now, if we will have one more 8 here, then in only in one subtraction we can decrease it to 2, 8, 4, 3, 3, 4, 6, 3, 6 now, or 3, 2, 3, 8. Okay, so it will contain a odd string. Okay, so if we have anything greater than the last digit in our string, then we can do it in two only. Two subtract. We will subtract first step. Means two is how? First is subtraction, then reorder. Two step. But if it is maximum only, see, if we have 246, the maximum number only, then we have to do it 240. Now we will have something smaller. Then we will subtract one more step. Then here we have to do two steps, two subtraction, then reorder. Okay, so we did you get it? What we are doing? We will see if any maximum part is there beside it. If it contain any maximum element digit larger than the last digit. If we have any digit larger than the last digit in our string, then we can do it in two only, two steps only. First subtract, then reorder. But if we have the maximum element at the last only, then we will take 3. Okay, so last digit is max in, and then our answer is 0, else our answer is, sorry, 3, else our answer is 2. Not, wait, last digit not equals to maximum. But what if when -1 will come? If 2, 4, 6, 8 is there only, then we can turn it to or 0. Then we can turn it to odd because we cannot minus or subtract it. So it will become that case. Okay. If the size of, so we will go to solution. If the size of solution, wait, I will do here like this. Okay. If n equals to 1 and it is odd, then we will return 0. Else it will become -1. Odd case, for odd we will return 0 this case. Okay, if we will see if the number is not even or not. If it is not even, means it contains a string which is odd, then it will cost us 1. Okay, see, it is also okay. If our last digit is 0 only, then we can return directly -1, means subtract any digit from it plus reorder, then this will become only two step. Okay, if maximum is greater than last one, then our answer will be 2. Last one is okay. If last equals to max, then our answer will come 3. Look at this question sorted. Now we will go to the rectangle coloring. Hey, now we will solve the question rectangle coloring. So I will give you something for a hint. It is something like this. It's a hint. If anyone wants to try this question first, then come back, then it will be very nice. You can think about this point. Okay. Now the question starts is like, see, we have L L W W, length W W, and we have, sorry, we have, okay, sorry, red, green, and blue color. Okay, so in the question you will know that. So RGB equals to LL plus W means what will be the length of that. So what we have to do, we have to paint each side of the triangle must be painted completely. Okay, a side may be painted using one or more colors. Means we can color size by red, RGB also, RR, RG also only, or blue color only like that, or RB color, or any permutation combination of this. We can color a particular like that also. Okay. So how many possibility of painting a color is? Suppose first of all R G B, then R G R B G B, then R G B. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7. 7 possibilities of each is there. Means each can be painted in seven type of colors. Okay. Each wall. Okay. Okay. So now what's the question is, we have to paint it with the minimum total cost required to paint entire bench. Okay, we are having a 7 possibilities for painting each. Okay, 7 patterns by which we can paint. Okay, so now we will determine the minimum cost of that. Okay. Okay. See, these problems look like greedy, but in greedy gives us the wrong answer generally. Because why it will give wrong answer, I will show that also, and why we will go with recursion. Hint, you can see these recursion. I will tell you. See, see we have a we have a triangle with the length a rectangle with a length of 2L plus B. We have to color with RGB. Okay, here it is that. So we have to see the list cost also. List. So what will be the greedy thought process is like take the big see I will short this. I will short this LLBB. I will short RGB and remove the biggest past. Means I will remove the biggest of this and biggest of this and remove that. Then biggest of this, remove that. If it will consider no, see if it will remove, I will take one color. And if it can't remove, I will take two colors. Like that only, no? With greedy, how we will go and solve. So in greedy, what I will do in greedy, I will take the largest color of this. If it will be possible to take all the color from this, I will take, or else I will take two colors, this and this. Okay. If not, I will take only one, like that. See, take what I will do, take the biggest color, give it the biggest size, and remove that set and repeat. That only we will do now. So what we will do in greedy, what we will do, take the biggest color, give it biggest side, remove the side, and repeat. That's what I will be doing now while sorting. But looks that see here the main question is cost is not equals to what you paint. It depends on the sites, how many sites. Okay, so we will see here what was my logic, means what we said firstly. We will see which site that means which site does this color attend touches, means for this site. See, suppose this is that, how many colors are present here, how many colors are present here, how many colors are present here, how many colors are present here. Okay, so how many subsets can we find? Is there are 2 to power 2 means there are, what are the possibilities? Each color can touch any non-empty subset of sites. Means suppose there are 4 sites now. See for R, wait, see, see for each color we can choose any of LL, WW, LL, WW. We can choose any. So what will be the probability of choosing one? Will be 2, because we can take, we cannot take, means like we can take this side, we cannot take, we can take this side, we cannot take, we can take this side, we can not take, we can take this side, we cannot take. So it will become 2 for 4 minus 1, because we have to take at least one side now, at least one side. means minusing this because it can't be null. Okay, for each we will have 2 q power 4 minus 1, 2 q power 4 minus 1. Okay, it will become 15. It has 15 case and it is 15 case total how much it becomes. 15 power 3 is 3375. So we can see, we can go through the recursive process and see thus R is going to L W or not, means like that. So what we will do in recursive approach, like we will process color one by one. For each color we will try to see that non-empty subset of sites, means we will try each, means first is like each subset of that. See for R what will be subsets: L1, L2, W1, W2, L1, L2, L1, W1, L1, W2, and L1, L2, W1, L1, L2, W2, like 15 cases will be there for R only. Okay, so what we will do, and we will also check what will be the minimum cost. We will check once where, and this works because we try every structure possibilities. So there is no greedy assumptions, therefore granted minimum cost. So in this, we will try every possibilities of each color and sets. Each color and sets. Thus we will get the minimum cost. Now how we will do, I will show that. See what is here in this. Now in the code we have a color of RGB, we have site LLWW, and our best is 3 into 4 into 12, means we can have each side with the color with 3 colors. Okay, so our best answer will be 12. Okay, for now. So we will have our DFS functions which will pass cost index, at which index we are at of the side we have is which. Okay, and we will, and these are the sites LLWW. Okay, now in the code what we are doing, see, we will see IDX is the index of the color, index of the colors. Okay, so for each color we will see how many possibilities are there. So it's 2 to the power 4 minus 1. Okay, so total how many solutions are? 16 solutions, 15 solutions are there for now. So in bitmasking, so see, in bitmasking, each num is presented at bits, means it is like LLWW is there. So if it is L is 1, if for each C, if we will select 2, so what it represent, that only W is present. Whichever site will be 1, means L C if LLWW is there. So according to bits, whichever bit is 1, that side we are taking for this concept. We are considering like whichever see sides are there, na? So sides of 0, V1, V2, V2, V3 is there. So it is like bit number. Which we will choose that size whose bit is set. Okay. If this bit is set, it means this side is taken. If this bit is set, it means this side is taken. Okay. So from 0 to 15, if that bit is set, we will understand that this side we are taking. Okay. Okay, we will see this. So now we will see into the code how the code is running. So we have taken RGB the colors, we have sorted, we have taken sides LLWW. I have shown you what is the best. Best is 12 for now. Means the best cost. What is the best cost for till now? Means there can be maximum cost can be 12. It can't be greater than 12. That's why. And what is DFS of 0? We will be calling this IND sites. And what is the cost till now? So for now the cost is 0. Okay. So here we will see if cost is greater than equals to best means 12. 12 means if our if suppose we have found some cost is 5 for now. If we are going for now our cost is 5, but for now our best cost is 5 and we are getting a solution whose cost is 7 for now. So we will directly return because we have get a solution which is far better than that. Okay. See, if IND equals to 3 means for R we have find the color, for G we have gone through color, for B also we have gone through all the colors. Means 0, 1, 2. Now our IND become 3. So it means we don't have any color for now. So we will return what will be the cost till now. Okay, minimum cost. Here we will see what is the minimum cost, and it means we have not gone to all the sets and get all the colors like that. Okay. Int need equals to color of mask means color of id means how many colors we have 7 colors means what is the count of that color means if it can be 6, r has the length 6, so we can color this by red color of length 6 and not this two like that. Okay, see we will see which size we are masking for now. Whatever the side we are masking, we will see what is the length of that, what are the total length of that. Okay, if then we will find the what are the that. Okay, so now what is the main problem is like here what is here if capacity is greater than needed means we have a capacity of sites. What are the sites remaining from that masking? Whichever will be one, we will get that site. Okay, and whatever the total site we will be adding in the cap. Suppose 6653 is there, and our this is our sites for now. So these bits are set for now. So what will be our cap for here? Here our cap will be 12 because these two sets are fixed. So we will attend these two. It can be decreased or that we will see down. Okay. If cap is greater than needed means our total capacity is greater than the what is our colors IND. It means suppose 9 is our color and it is greater than that. So we will not do that. We will directly continue and remove from this process. Okay. Now what is the end sites? First of all, we are going for each mask from 0 to 15. That 0, 0, 0, 0, 0, 0, 0, 0, 1. We will see each point. Okay. We will go inside this and we will send what is the capacity. Capacity. Okay. If the capacity is greater than needed, we will continue. See what is hap- see what is happening inside this loop is like we don't care about how the distribution will be there. We will only be careful about how what is the distribution existing. So if there is a site, these four sites are there. Okay, suppose for now these four sites are there. I will take any part of this. I will take suppose X part of this, Y part of this, Z part of this, and 0 part of this. It's okay for me. So I will take whatever will the minimum of that set and just divide it by that. What will be the remaining? R minus X means L minus X, L minus Y, W minus Z, and W minus 0. So for now. Okay. Now this side will become our new sites. Okay. For now. Okay. You got it. And this will call the another loop of this where we will increase the indexes and see what is the mask for other sets like that, and it will generate all the masks for us. Okay, thank you. From this. Okay, dfs ind1 and end set, and we will return the what was the biggest. It will give how many cost means how many sites were there like that. Mask. If it is 1110, it will give us 3. If it is 1100, it will give 2. It is 1001, and count of 1 it will give in a particular number in Bitmask. Okay. Okay.